Okay, so good morning, class. So we will discuss the shear strength of the soil. Okay, so the shear strength of the soil is the internal resistance per unit area of the soil. It also resists failure and sliding along the any plane inside it. So in this figure, we have the example of shear failure in a soil. Okay, so as you can see, nag-slide yung portion nung soil na to. Okay, so engineers must understand the nature of the shearing resistance in order to analyze the soil stability problems. Okay, such as the bearing capacity, the slope stability, and the lateral earth pressure or lateral pressure on earth retaining structures. Okay, so that is the purpose of the understanding the shear strength of the soil. So the soils generally fail in shear. Okay, so for example, we have strip footing or an isolated footing. Then after loading, okay, let's try. So after applying a load on top, okay, then magge-generate ng failure surface na ganito. This one is what we call the failure surface. So ito yung line na kung saan magkakaroon ng maaring magkaroon ng failure in shear. So this one is what we call the failure surface. So for the embankment naman, this one, yung let's say the soil slope stability of infinite soil, yan. Let's say this one. So for example, embankment, then to mobilize the shear resistance, we have also the failure surface at this portion. Okay, this one is the failure surface. So at failure, the shear stress along the failure surface reaches the shear strength. Okay? So shear strength is used to analyze, katulad kanina, the bearing capacity, the slope stability, and the retaining walls. Okay? Then also, the shear strength is a function of cohesion between the soil grain, the frictional resistance between the soil grain, and the effective normal stress on the failure plane. So let's say for example this one. Then kumuha tayo ng isang, let's say two soil particles. So kumuha tayo ng dalawang soil particle. This one. Yan, this one. Then isa pa dito. Okay. The shear strength, okay, yung two soil particle na yan, this one. Okay, the cohesion between the soil grain or the frictional resistance between the two soils is main contributor for the shear strength of the soil. Okay, so maybe this frictional resistance, and this one, yung frictional resistance dito, and this and dito, yan. Is the main contributor of the soil, also the cohesion between the soil grains. Okay, then the soil particles make contact with adjacent particles so that the friction develops. So then the shear strength is the ultimate or maximum shear stress the soil can withstand. Okay, also the shear strength is the internal resistance of soil to the shear failure. And the shear strength is defined as the shear force at failure per unit area of the failure plane. So shear strength can be determined in several ways, pwedeng laboratory test and field test. Okay, in laboratory test, we have three. So we have the direct shear test, we have the triaxial shear test, and the unconfined compression test. Okay. Unfortunately, I think hindi natin to makakantak. So yung direct shear test, the triaxial shear test, and the unconfined compression test. So due to current situation. Then due to field test, we have the vein shear test, we have the Torvein shear test, and the standard penetration test. Okay. So the question is, how can we predict failure? So let's say if failure, diba, we will determine the capacity and the demand. Diba, yun lang naman yung concept if you want to find if if we want to find that our components or structural component is fail or safe. So just we need to find the capacity versus the demand. Okay? Yun lang naman yung kailangan nating hanapin. Okay. So for the Mohr-Coulomb failure criterion, this one. So for brittle materials, we have different failure theories. And for ductile materials, we have also different failure theories. Okay, so this one is the sources for understanding failure theories. So you can check this on YouTube. Okay, so going back, these failure theories, we have the brittle material and ductile material. So I give you an overview of these failure theories, different failure theories. So if you recall the 0.6 Fy in steel, the 0.6 Fy in steel. Okay, this one is your capacity. Let's say this one is your capacity, stress capacity on steel, diba? Napansin niyo na ba yung 0.6 Fy, class? This one is your shear, let's say capacity on steel, diba? In tension. So this is based on the von Mises theory or the von Mises failure theories. So we all know that steel is a ductile material, diba? So according to the von Mises theory, we can relate the failure of steel based on the yield, on its yield strength. Okay, so that's why they have factor 0.6. Okay, so that is 0.6 Fy. So in a case of brittle materials, just like a soil, yan, brittle materials yung soil. Okay, so the best and not the best, maybe yung simplified failure theories is this Coulomb-Mohr theories. Coulomb-Mohr or Mohr-Coulomb failure criterion. Okay, then there is a modified version of Coulomb-Mohr. There we have the modified Mohr. Okay, this one is modified Coulomb-Mohr failure criterion. Okay, so this one is for the brittle material. So if you want to check other failure theories, you can also check this video in YouTube. Okay, so the failure of brittle materials is of course at fracture. So brittle materials failure occurs at fracture. So if we check the stress and strain diagram of a brittle material, so this one is the graph of a brittle material or the stress strain graph of a brittle material. As you can see that the compression or the compressive strength of brittle material is much larger than its ultimate strength. Okay, so therefore our soil also is much greater in compression than in tension. So therefore we can say that our soil is a brittle material. So it's an example of a brittle material. Okay, so for the Mohr-Coulomb failure criterion, so the Mohr circle is drawn by uniaxial test, maybe tensile and compressive stress. So graph yung dalawa, this one and this one. Okay, then that is your principal stress. Okay, the uniaxial tensile or compressive stress is your principal stress. So more on this in this discussion later. Okay, then by drawing the tangent line, we have the failure plane. This one is the failure plane. So anything above or within this area, we can say that our soil is not safe or fail, diba? So yan. So anything about inside this failure area is not safe. So Mohr in 1900 presented a theory for rupture in materials that contended the material fails because of a critical combination of normal stress and the shear stress. and not from either the maximum normal or the shear stress alone. So the functional relationship between the normal stress and the shear stress can be expressed in this following form. So according to Mohr, that the shear stress is a function of a normal stress. Okay, then the failure envelope defined by the equation above is a curved line. So this one is a curved line. So for most soil mechanics problem, it is sufficient to approximate the shear stress on the failure plane as a linear function. So if you recall the uh, failure plane natin kanina, this one, yung failure plane natin kanina, this is a curved line, di ba? This is a curved line. So in most soil mechanics problem, ina-approximate nila to as a straight line para mas madaling ma-understand yung problem or mas madaling ma-solve yung problem. Okay, so that is why in the Coulomb in 1776, kaya siya ginawang Mohr-Coulomb failure criterion. So pinagsama nila yung theory ni Mohr in 1900 and the approximation of Coulomb in 1776. So that is why it is sufficient to approximate the shear stress on the failure plane as a linear function. So this one is a curved line. This one is for curved line. And this one is incorporation of a linear function. Okay, that is why your shear stress is now equals to the cohesion plus the normal stress on failure plane tangent of phi, whereas your phi is the angle of internal friction. Okay. Then for saturated soil, we all know that for saturated soil, the normal stress, the total stress is equals to the effective stress plus the pore water pressure. Okay, therefore, the all stresses will be based on effective stress. Okay, this will be based on effective stress. So now your Mohr-Coulomb function or the linear function like this one will now be equal to shear stress equals to C plus phi prime tangent of sigma prime tangent of phi prime, whereas your sigma prime is the effective stress, okay, and phi prime is the angle of friction and is sometimes referred as the drain angle of friction. So this one is drain angle of friction. Pag walang prime, that is an angle of internal friction. So take note, class, that for sands and organic silt and for normally consolidated clays, the value of your cohesion, C, this one, is equals to 0. And for over-consolidated clay, I think you all know by now what is normally consolidated and over-consolidated. And for over-consolidated, the value of cohesion is greater than 0. Okay, sorry. That is for over-consolidated clays. Then we have also the typical values of drain angle of friction for sands and silts. Okay, so this table shows a different value of drain angle of friction. So for sand rounded grain, so for loose we have 27 to 30, for medium we have 30 to 35, for dense we have 35 to 38. And for sand that is angular grains, okay, we have 30 to 35 for loose, 35 to 40 for medium, and 40 to 45 for dense. Then for gravel with some sand, we have an angle of internal friction or the drain angle of friction. We have 34 to 48. And for silts, we have 26 to 35. So this table is important if you are having your preliminary design in earth retaining structure or the isolated footing. So you need this value or this table. Okay, so just like what I said kanina, let's say we have this failure surface and this have a strip footing. So let's zoom in. Let's say try natin i-zoom in. Okay. So this one is your failure surface. Yan, failure surface natin yan when a load is applied on top or at the strip footing. So if we get a soil particle on the failure surface, this one, if we get a if we get this one, okay, makikita nyo yung failure surface. Ito siya, this one, magiging ito na yung failure surface. So magiging straight line siya or linear if we incorporate the new formula or the Mohr-Coulomb criterion. We have this one, yung shear stress that is equals to cohesion plus the normal stress and the tangent of internal friction. Okay, so that is why your stress element, we call this one a stress element. That is your soil particle or an element inside the failure surface. So makikita niyo yung failure plane na ito. That is also already a straight line. So a stress element can be converted to in this graph, yan, graph na ito, we call this the Mohr-Coulomb, Mohr circle, this one. So there is a load in the failure plane normal to the failure plane, that is phi prime, and the parallel to the failure plane, that is the tau or the shear. Okay, then the stress element is have the phi x prime or the compression or tension, and this one or compression and tension on the vertical axis, this one. Then also they have a shear xy and shear xy. Okay, so you can convert this stress element to a Mohr circle. So this one is your Mohr circle with effective normal stress phi prime in the x-axis and shear stress tau on the y-axis. Okay, then the inclination of the plane of a failure caused by shear. So another example of stress element with a failure plane surface, this one, the failure plane. So the angle theta or the angle of the failure plane from the horizontal plane or from the major plane, okay, we call it a major plane. So this one, phi1 prime and phi p, sigma prime 1 and sigma prime 3. Okay, sigma prime 1, we call it as the major principal stress. So it is yung normal stress without the shear stress. So normal stress alone lang siya. Then the sigma prime 3 is the minor principal stress. Okay, that is why yung this plane is the major principal plane. Kasi nandito yung major principal stress mo. So that is your major principal plane. And this one is your minor principal plane. Okay? Kasi nandito yung minor principal stress mo. And the angle theta, this one, the angle theta is the angle from the major principal plane and the your failure surface. This one, di ba ito yung failure surface natin na linear na. This one is your major plane. So that is why your angle theta is, according to the figure, the angle theta is the angle between the major principal plane and the plane surface or the failure surface pala, sorry. Okay. The line FGH, okay, the line FGH, F and G and H, this one, the line FGH is the failure envelope defined by the function tau is equals to C plus phi prime tangent phi prime. So that is your linear graph. Okay. Then the line AD, okay, this one, the line AD, ito, The line AD defines as your failure plane EF. Okay, that is your failure plane EF. Yes, one. Yung line AD natin defines the failure plane EF. Okay, and the line AB, this one, the line AV defines as the major principal plane CD. Okay, the major principal plane CD. So if we convert this stress element to a Mohr circle, your theta is twice of that angle in the Mohr circle. So lagi siyang nagta-times 2. Okay? So theta dito magiging twice 2 theta. Okay, this one is your AB. Ito rin yung AB mo dito. And this AD is your EF dito. Okay? So that is your that is how to convert the stress element to a Mohr circle. So more on this in example problem. So medyo mas madali nyo siyang maiintindihan. Okay, then the line, the slope of the line FGH is the phi prime, or the angle of drain frictional resistance. Yan. Okay, so considering the angle BAD, this one, consider natin yung angle BAD. So consider angle BAD. Yan. So that is 2 theta, di ba? Then 2 theta is also equal to 90 plus phi prime. Okay? So if we draw a line here, that is already a 90 degrees. Okay, 90 degrees yan dito. So if this is phi prime, therefore this is also phi prime, di ba? So that is why your 2 theta is equals to 90 degrees plus phi prime. And solving for theta alone, divide all terms by 2, we get 45 plus phi prime over 2. Okay? Then sine phi prime, this one, the sine phi prime is equals to, okay, that is AD over the AFA, or the line FA. So let's say this one. Okay. This one. Your sine phi prime, this one. Let's say we get this triangle. Okay, we get this triangle. This is the 90 degrees. So ito, no, so sine phi prime natin is opposite over hypotenuse. So that is why we have line AD over hypotenuse FA. So that is your sine phi prime. And AD, your AD is the radius of your Mohr circle. This one of this semicircle, di ba? That is your radius. So finding the radius, that is equals to phi1 prime minus phi3 prime over 2. So get the diameter divided by 2. That is your radius. Okay, then we can say that FA, the line FA, is equals to FO plus OA. Okay, so that is your working equation. That is our working equation for this time. Then the tangent phi prime, also that tangent phi prime, this one, the tangent phi prime. So we get this triangle over here. And okay, so tangent phi prime is opposite over adjacent. We have C, the cohesion value over FO. Okay, therefore our FO is C cotangent phi prime. Okay, then your OA now this time is phi3 prime. Tama. That is the value of phi3 prime, or the minor principal stress. Okay, this one, plus the radius is your length OA. That is your length OA. So inserting the value of the radius of the AD, that is this one. So you have your OA na phi 3 prime plus phi 1 prime minus phi 3 prime over 2. So simplifying, we have this one. So multiply all terms by 2. We got 2p sigma prime 3 plus sigma prime 1 minus sigma prime 3 over 2. That is equals to sigma prime 3 plus sigma prime 1 over 2. Okay. So we now have our OA, this one. So yung FA na lang. Okay. So yung FA natin, since we have FO, this one, yung FO natin na to, plus the line OA. So therefore, our FO and our FA value is C cotangent phi prime plus sigma prime 3 plus sigma prime 1 over 2. Thus, our sine phi prime, this one, yung AD over FA, that is equals to the radius over the line FA. So that is sigma prime 1 minus sigma prime 3 over 2 divided by C cotangent phi prime plus sigma prime 3 plus sigma prime 1 over 2. Okay, rearranging this equation and multiplying and cross multiplying and using cotangent phi prime, that is equals to cosine phi prime over sine phi prime. Okay, so yung sine dito makawawala, magiging cosine na lang siya. So that is why C cosine phi prime. Then yung sine phi prime dito, mamumultiply dito. So that is why sine phi prime, then sigma prime 3, sigma prime 1 over 2. Then ito as is. So that is sigma prime 1 minus sigma prime 3 over 2. Then simplifying all terms and tatanggalin natin yung denominator. So multiply all terms by 2. So we get C, this one, 2C cosine phi prime plus sine phi prime. Then yung sigma prime 3 and sigma prime 1. Then yung denominator nito is nawala din. That is now sigma prime 1 minus sigma prime 3. Okay. Then substituting the value of sine phi prime. So multiply mo dito and multiply mo rin dito. So we have 2C cosine phi prime plus sigma 3 prime sine phi prime plus the sigma prime 1 sine phi prime equals to sigma prime 1 minus sigma prime 3. Okay, so solving for sigma prime 1 or rearranging, so papagsamahin lang natin yung may sigma prime 3 and sigma prime 1. So kung ipagsama mo to, so ito ipunta mo sa kabila, yung sigma prime 3, then yung sigma prime 1 ipunta mo sa kabila. So then factoring out sigma prime 3 and sigma prime 1, you have this equation over here. So therefore, we can say that our sigma prime 1 is equals to 2C cosine phi prime plus sigma prime 3, then 1 plus sine phi prime all over 1 minus sine phi prime equals to sigma prime 1. Okay, this one is your major principal stress. Then by trigonometric identity, so if you check this trigonometric identity, so tangent 45 degrees plus phi over 2 is cosine phi over 1 minus sine phi. And for tangent squared 45 plus phi over 2, you have 1 plus sine phi over 1 minus sine phi. So this is a trigonometric identity. So using this trigonometric identity, we can say that our value of cosine phi prime, then 1 minus phi prime is this one. And the value of 1 plus sine phi prime minus over 1 minus sine phi prime is this one, tangent squared 45 plus phi over 2. Then going back to our value of theta, this one, the value of theta, that is 45 plus phi prime over 2, this one. So we can say also that our sigma prime 1 is equals to 2C tangent theta plus sigma prime 3 tangent squared theta. So this is your formula for the sigma prime 1 and sigma prime 3. Okay, so you can use this formula as is, or pwede rin by using geometry, basic geometry. Okay, So for the laboratory test to determine the shear stress, so we have the direct shear test and the triaxial shear test and the unconfined compression test. So using the direct shear test, so yung direct shear test is the oldest and simplest form of shear test arrangement. Okay, so we have this direct shear test or in the CE laboratory. So kung nakapunta na kayo sa CE laboratory, this is your direct shear test, on direct shear test. So you have this one, yung direct shear apparatus. So mag-a-apply ka ng normal force on top and the shear force at the bottom. Okay? Yung test equipment consists of a metal box or metal shear box. Ito, nakikita nyo na to. Then, in which a soil specimen is placed. The soil specimen may be square or circular in plan. The size of the specimen generally used is about 51 mm or 102 mm. Okay, so 51 by 51 mm or 102 by 102 mm across and about 25 mmi. So the box is split horizontally into halves. So normal force in the specimen is applied from the top of the shear box. And the normal stress on the specimen can be as great as to 1050 kilonewton per square meter or 1050 kPa. And the shear force is applied by moving one half of the box relative to the other to cause the failure on the soil specimen. Okay, so if you want to, if we check the stress element, okay, let's say we study the stress element over here. Yan, study natin itong stress element dito. So yung stress element dyan, tama ba na may normal force ka lang sa taas and may shear force ka, okay, may shear force ka dito. Okay, this one. Okay, so that is the direct shear test. Okay, so the analysis of test result. Okay, the analysis of test result, your normal stress is equals to the normal force over the area of the cross section of the sample, and the shear stress is the shear resistance developing at the sliding surface over the area of the cross section of the sample. Okay, so that is this one is this yung soil ano natin. So stress element yan. Dito yung shear stress, let's say dito yung shear stress. Okay. Yan. Okay, so take note, in direct shear test, the cross-sectional area of the sample changes with horizontal displacement. So syempre, nagbabago yung cross-sectional area niya kapag nag-apply ka ng shear stress sa gilid, di ba? Pag tinulak mo yung shear box, yung cross-sectional area niya is lumiliit. Okay, di ba? Lumiliit yung cross-sectional resistance niya or yung nagde-develop ng area, yung contact area. So that is why the cross-sectional area of the sample changes with the horizontal displacement. Okay, if we graph yung na-compute natin sa laboratory for the normal stress and the shear stress, so this one is an example of the graph of determination of shear stress parameters for a dry sand using the result of the direct shear test. Okay, so ipo-plot lang yung effective normal stress and the shear stress. So, di ba there we have a corresponding value of effective normal stress, then meron siyang combination ng shear stress. So, ipo-plot sila isa-isa, then you can create this graph. Then for the direct shear test, ito na nga yung stress element natin. So, for sands and organic silt and normally consolidated clay, the value of C is equals to 0. And for over-consolidated clay, your value of C is greater than 0 or you have a cohesion value. So the direct shear tests are drained and the pore water pressure is dissipated. Hence, we can say that our pore water pressure is 0. Therefore, so your drain angle of friction is equals to phi and your C prime is equals to C. Okay? So wala siyang difference yung may drain and yung may effective normal stress based on effective normal stress. Okay, then we also have the triaxial shear test. So in the triaxial shear test, it is one of the most reliable methods in determining the shear strength parameters. So we also have the triaxial shear test in our laboratory. So ito yung setup na yun. Ito yung pang triaxial shear test. So we have the specimen preparation, undisturbed sample. Okay, that's one. So for the standard types of the triaxial test, the consolidated drain test or the drain test, we have the CD test. We have the consolidated undrained test or the CU test, and the unconsolidated undrained test or the undrained test, or we call it as UU test. So we have three: CD test, CU test, and UU test. So basically combination lang to ng consolidated and drain. So pwedeng consolidated, drain, consolidated, undrain, unconsolidated, undrain. Okay? Then wala lang yung isa. So for the triaxial shear test, so this is your triaxial shear test apparatus, this one. So you have an actual load, a loading ram. Then you have an air releasing valve. Then you have this water. Okay? So pwede siyang submerged on water. Okay? So this one is your water. This is your porous disc. And this one is your specimen in a rubber membrane. So kung nakakita na kayo ng conduct ng triaxial test, yung specimen is balot ng rubber membrane. Okay? Then yung rubber ring at top and yung flexible tube is magsisilbing pang-release nung pag-drain or pag-undrain ng ating specimen. So depending niyang i-drain yung water or pwedeng hindi i-drain yung water. Then we also have the pressure gauge. Okay, over here, and this one yung labasan ng drainage of pore water pressure. So we have two cases for the triaxial test. So under step 1, under all around cell pressure. So the question is the drainage valve open? So pag yes, that is consolidated sample. Kapag no, that is unconsolidated sample. Okay, for deviatoric stress, so maglalagay ka na ng tubig. So we call the pore water pressure also as deviatoric stress. This one, deviatoric stress. So kapag the question is if the valve is open, you have the drain loading, and if the valve is closed, you have the undrained loading. Okay, so for consolidated drain test or drain test, the CD test, then consolidated drain test. Yung first subjected to an all-around loading confining pressure sigma 3. Then as your sigma 3 increases, the pore water pressure increases. So take note that yung drainage is prevented. Okay? So piniprevent pa yung drainage of pore water pressure. Then the increase in the pore water pressure is expressed as Skempton parameter. So the Skempton parameter is U sub C over sigma 3, or your pore water pressure and your sigma 3, or yung normal stress mo dun sa dito, in this one. So your value of the Skempton parameter, B equals 1 for saturated soft soils, and B that is less than 1 for saturated stiff soils. So yung as the drainage is kept open, the excess pore water pressure is dissipated and consolidation occurs. So with time, U sub C becomes 0. And since your U is equals to 0, the pore water pressure is 0 in CD test. Your phi is equals to phi prime. Sigma is equals to sigma prime. And your cohesion is equals to C prime. And your phi is equals to phi prime then. So sometimes the CD and phi D are used as symbols for cohesion and angle of friction. Okay? So your sigma 1, take note that your sigma 1 is equals to sigma 3 plus delta sigma or yung deviatoric stress mo sa top. Okay, yan. That is your sigma 1. Or we can say that the deviatoric stress delta sigma D is equals to sigma 1 minus sigma 3. Okay. Then the graph of a consolidated drain test or CD test is can be written as this one. Then kapag may cohesion value, pwedeng ganito yung itsura. Okay. So mapapansin nyo class, deviatoric stress delta sigma D is the difference of your sigma 1 and sigma 3. And also that is your diameter or the diameter of your Mohr circle in this one. Okay. So more on this if we try, if we try a sample problem next meeting. Okay, then for the triaxial shear test or the CU test ng consolidated undrained test. So first, subject to an all-around confining pressure sigma 3 that results in drainage. Then after U is dissipated, U sub C is equals to 0 and your delta sigma D or the deviatoric stress is increased to cause shear failure. So the drainage is kept closed, the drainage is not permitted, then additional pore water pressure is increases. Then the increase in the pore water pressure is expressed as the Skempton pore pressure parameter. That is your delta U sub D or the change in pore water pressure over the change in deviatoric stress. So that is your Skempton's pore pressure parameter. So for the consolidated undrained test or the CU test, unlike the CD test, the total and effective principal stresses are not the same in the CU test. The pore water pressures measured at this test, then the principal stresses are analyzed as follows. Yung major principal stress at failure is equals to sigma 3 plus your delta sigma D or the deviatoric stress that is equals to sigma 1. Then for the major principal stress at failure ineffective based on effective stresses, okay, your sigma 1 minus your pore water change in pore water pressure, that is your equals to sigma prime 1. Okay, the minor principal stress at failure or that is sigma 3, and the minor principal stress at failure ineffective, that is your sigma 3 minus the pore water pressure, that is equals to sigma prime 3 or the effective stress based on effective stress. So kung mapapansin nyo, parehas lang siya doon sa formula na normal stress, total stress minus the pore water pressure is your effective stress. Okay, so that is why this one, total stress minus the pore water pressure is your sigma prime 1. And total stress minus the pore water pressure is yung effective stress na to. So therefore, we can say that the difference between the total stress sigma 1 and sigma 3 is equals to the difference of sigma prime 1 minus sigma prime 3. Okay, so if we try to graph yung CU test, is this one. Okay. This is the graph of the Mohr circle of total and effective stress failure envelope for consolidated undrained triaxial test. Okay, kung mapapansin nyo that C1 and C3, this one, C1 and C3, ito yung difference ng C sub 1 and C sub 3. This is the difference of C sub 1. Okay, this one is C sub 1. Sigma sub 1 minus sigma sub 3. And this is the difference of sigma prime 1 minus sigma prime 3. So that is the diameter of this Mohr circle and the diameter of this Mohr circle. Okay? So ano lang siya, nag-move lang siya paatras. By how much? By the pore water pressure. By this change in pore water pressure. Okay? So ganyan yung pag-graph ng consolidated undrained test. So this one is this graph, itong graph na to, solid blue line is the total stress failure envelope. So it's just simply tau phi tangent sigma tangent phi, since no cohesion value at initial, no cohesion value. So ito lang yung graph na yon. Then ito naman yung broken lines, that is just effective stress failure envelope. So mapapansin nyo may prime na doon and may prime na doon, denoting for the effective stress. So that is shear stress is equals to effective stress plus tangent phi prime. So yung angle mo dito, that is now your phi, and yung angle mo dito, that is now your phi prime. Okay? So ito yung first trial mo. Let's say this is your first trial. Then changing the pore water pressure, ito yung nangyari doon sa first trial mo. Then let's say ito yung second trial mo sa laboratory. Then applying the change in pore water pressure, ito yung nangyari doon sa second trial mo. Okay, ito yung nangyari sa second trial mo. Then using Excel or any graphing tools, so you can create a line over here, or an equation of the line over here, an equation of the line over here, making a tangent line to the Mohr circle. Your Mohr circle, this one. Your point tangent at this point, tangent at this point, and tangent at this point, then tangent at this point. So that is how you find the shear strength using the consolidated undrained test. Okay. Then for the triaxial shear test or the UU test naman, for UU test or the unconsolidated undrained test. So this test depends on a very important strength characteristics if the cohesive soil is fully saturated. So in UU test, the drainage is not permitted during the application of sigma 3. So no drainage is likewise allowed during the application of your deviatoric stress. So since U, or the pore water pressure, is U plus U sub C plus delta U sub D, but since your U sub C is by Skempton parameter B, sigma 3, and your delta U sub D is yung Skempton parameter A multiplied by delta sigma D. Hence, we can say that your U is B sigma 3 plus A delta sigma D, or that is equivalent to B sigma 3 plus A sigma 1 minus sigma 3, since the delta sigma D is just the diameter of the Mohr circle, or equivalent to sigma 1 minus sigma 3, or this one is the deviatoric stress. So for the unconsolidated undrained test, okay, ito yung Mohr circle na makikita natin for unconsolidated undrained test. So let's say we have this one. Ito yung first trial mo. Okay, the total stress of Mohr circle at failure. Okay, so we have the C sub U, that is equals to your shear stress, maximum shear stress. And your phi is equal to 0. Therefore, your failure envelope phi is equals to 0. So ito yung failure envelope mo. Okay, so the total stress of the Mohr circle and the failure envelope phi is equals to 0 obtained from the unconsolidated undrained test on a fully saturated cohesive soil. So this one maybe is your first trial, this one is your second trial, and this one is your third trial. So for another special type for unconsolidated undrained test, commonly used for clay specimen, is we have the unconfined compression test. So for the unconfined compression test, it's just simply kukuha ka ng soil sample, then you will do compression test doon sa soil sample mo na yon. So para ka lang compressive test doon sa soil sample imbes na tulad sa concrete na UTM, dito naman medyo mas mababa lang yung pang compression test mo. So hindi rin ganoon kalaki yung soil sample mo. Okay, so the confining pressure is 0, so hindi mo siya kino-confine. Then the actual load is applied rapidly to a failure. So your tau F or your shear stress is equals to your sigma 1 over 2. Very basic na yung Q sub U mo over 2, or that is also your cohesion value. So and just simply lang to, force over area of the load applied on your compression test or the clay specimen. Then your the confined compression stress or your sigma 3 mo, yung pang-confining pressure mo, that is equals to 0. Okay. Then we also have the sensitivity and the exotrophy of clay. So for many saturated deposited clay soils, the unconfined compression stress is reduced greatly when the soil are tested after remolding without any change of the moisture content. So yung pag-change nung unconfined compression test strength mo is mababawasan. That is due to the sensitivity of the soil. So sensitivity means kapag disturb mo yung soil or undisturbed yung soil. Okay, so syempre, kapag undisturbed yung soil, mas malakas yung ibibigay niya na unconfined compressive strength. Okay, kapag remolded mo siya, nagulo yung soil, medyo bababa siya. Okay, so that phenomenon is called the sensitivity of the clay soils. Okay, so the sensitivity formula is the shear strength for the undisturbed soil divided by the shear strength on remolded soils. So for the sensitivity ratio for most clays, it ranges from about 1 to 8. However, for highly flocculent marine clay deposits, it has a sensitivity ratio from 10 to 80. So this example, this figure or this table shows the sensitivity of clay in different classification of soil. So classification of sensitivity. So kapag ang sensitivity value is 1, that is insensitive. So ibig sabihin, your undisturbed shear strength or the cohesion of the undisturbed is always equal to the shear strength and or the cohesion strength of remolded soil. Then for slightly sensitive, the value of sensitivity is 1 to 2. For medium sensitive, that is 2 to 4. Very sensitive, that is 4 to 8. Slightly quick, 8 to 16. Medium quick sensitivity, that is 16 to 32. Very quick, that is 32 to 64. And the all greater than 64 is extra quick sensitivity. Okay, then the loss of strength of clay soils from remolding is caused primarily by the destruction of the clay particle structure that was developed during the original process of sedimentation, or maybe due to construction, diba? Construction development. So if however, after remolding a soil specimen and it is kept undisturbed state for a long period of time without changing the moisture content, babalik po yung lakas niya at it will gain strength with respect to time. So yung pagbalik ng strength ng ating soil or ating clay ay tinatawag na thixotrophy. Okay, so it is a time-dependent and reversible process in which the materials under the constant composition and volume is babalik yung magigain siya ng strength with time. Okay, so that is thixotrophy. So for the additional readings, we have, please check this YouTube video. So Mohr-Coulomb, okay, understanding the stress transformation of Mohr-Coulomb, the triaxial shear test, and the direct shear test. Okay, so for the reference of our discussion, we have this Das and Siva Kugan Fundamentals of Geotechnical Engineering, Holtz and Shannon and by Kovacs in Introduction to Geotechnical Engineering. We have the Principles of Geotechnical Engineering by Das, and lecture notes of Foundation Engineering by Dr. Marcos. Okay, so if you have any question, class, please ask your question for topic. Okay, so I will make tawag dito ng summary for the different laboratory tests. So this one, direct shear test, triaxial shear test, and the unconfined compression test. So kasi di ba every laboratory test you have different Mohr circle, di ba? Different Mohr circle natin. So maybe I can give summary for different Mohr circle para doon na lang kayo titingin. Okay, so upload ko na lang siya maybe within the day. Okay, so next meeting we'll be having your sorry, hindi pa pala. So next meeting magkakandak tayo ng different example problem. So try natin mag-solve for different example problem. Maybe 2 sessions siguro tayo for example problem in shear strength. Sige, next meeting na lang yung Friday. So Monday. So next meeting will be February 7. Okay, next meeting natin is February 7 na. So for sorry, February 6 pala, February. Tama nga, February 7. Ba't ganito yung ano ko? Okay, so next meeting natin is February 7. So please study niyo yung this one, yung different graph in pag-apply ng Mohr circle, stress element to Mohr circle, para pagdating ng example problem natin medyo mas nakakasabay na kayo. Okay, class? So next meeting natin is Monday.
Okay po, sir.
Okay.